Begin the recording. Okay then. So welcome everyone to today's class. This is heat lecture number 1414. Okay. Do we recollect what we were doing in the last class? I think we were doing a question of JEE. And are you sure that you have understood that question? One point was 400 degrees, the other point was 0 degree, the other point was 100 degree. Ice was melting at one end and water was boiling at the other end. We understand that question? We remember it? Anyone understands that question that we had done in the previous class?
Yes, sir.
Good. Then we are supposed to do the next topic, which is radiation. But before going on to radiation, I'm going to take a risk. And risk is all about, life is all about risk. I don't know why I'm doing this, but well, let me try this. I'm opening up a Pandora's box, and let us see what happens when I open this Pandora's box. Okay, do we remember this question? There was this rod here. Let me call the resistance of this rod as R1. This was, let us say, at temperature θ1. This rod has a resistance R2. This temperature, let us take it as θ2. This rod had a resistance R3. We take the temperature as T3. And if I call the temperature of this junction as theta, do you know how to find out the value of this theta? Do we remember how will we find out the value of this theta?
Yes, sir.
How? What will you do? How will you go ahead and find out the value of this theta? This is the most general question that I can make here. And again, I'm opening up Pandora's box. I don't know what comes out of it. Huh?
Theta minus θ1 by R1.
Okay, so basically what you're going to do, you are going to make current like this. Let us call this current as I1. Yes or no?
Yes, sir.
Let us call this current as?
I2.
And let us call this current as I3 in your head. And that is good that you have done this. In your head, you have made an equation that I1 plus I2 plus I3 is 0. Am I correct?
Yes, sir.
This equation is in your head. Well done. So this is equal to 0. Everyone understands this?
Yes, sir.
Up till here? Girls, boys, raise hands.
Yes,
Okay. Yes, go ahead. Now what you are telling me, how did you get the value of theta? Tell me.
I1 equal to.
So you don't have to say that this is I1. You can straight away say theta minus
Theta
minus θ1 divided by
R1.
R1. Very good. Plus
θ2 minus theta by R.
Think. Look at the diagram. Look at the diagram. Look at the diagram. Look at the arrow. Look at the arrow. Look at the arrow. Look at the arrow. Look at the diagram. Look at the arrow. Look at the diagram. Look at the arrow. Yes, give me the answer now.
Theta minus θ2 by R2.
Theta minus θ2 by R2. That is my yellow gentleman. Okay, what about the third one?
Theta 3 by R3.
So if I call this as the pink gentleman, this pink gentleman will become theta minus θ3 divided by R3. That must be equal to
0.
0. From here, can you calculate the value of theta straight away? Yes or no?
Yes, sir.
Can you tell me what will be the formula that comes when I just straight away, without solving anything, what will be the value of theta? Tell me what will be the value of theta.
θ1 by R1 plus θ2 by R2 plus θ3 by R3
divided by
R1 plus 1 by
divided by not R1 plus R2.
1 by R1 plus 1 by R2 plus 1 by R3.
So basically it will be theta I by Ri ka summation divided by summation of 1 by Ri. Yes or no?
Yes, sir.
We all understand this?
Yes.
Now this is what I call the Pandora's box. Now way back in the year 1995, I was of your age. You were probably not born. I was of your age and I did thermodynamics. And obviously, I told you I came across this question, and the same question came in JEE as well. So I came across this question, and the same thing I did. Maybe my terms were different, theta 1, something was different. So I got the value of this theta, and then I understood that I could use this and find out solve some questions in a different topic altogether, and the different topic altogether was electric current. And then I started using this thing to solve electrical circuits, and I thought that I am very intelligent and I've discovered something. But then when I grew up, I realized that this thing was already known by a name, and the name is known as the Nodal Theorem. Have you come across this term, Nodal Theorem? You might not have. Nodal Theorem. Okay, the way Nodal Theorem is given in books, if you can find a book where you find this, would be somehow different to what I am going to tell you. Nodal theorem, to understand what do I mean by nodal theorem, you have to understand the term node. What do you think is a node? Now this node is nothing but any point, any junction where two or three, not two, more than two branches are meeting. So if I call this point as O, this O happens to be a node, because at this node, three branches are meeting. Do you understand this?
Sir.
At point O, three branches are meeting. I can call it a node. And if I call it a node and then I apply this concept in a different chapter, I will come up with some amazing results. What are the amazing results that I can come up with? So what I'll do is, again, I'm opening up Pandora's box, which is not in this chapter altogether. It's a different chapter. What I'm going to do is, I'm going to draw an electrical circuit so that I can just make some things and just make a valid point. Okay, this is the most general form of an electrical circuit that you will ever come across. A two-branch circuit, E1 R1, E2 R2. I hope you understand the meaning of what I'm writing here.
Yes, sir.
Now, the basic question here would be, how are you going to solve this? You can definitely solve it. You know that there are two loops, yes or no? Sure. You can call one loop as this, the inner loop. You can call the other loop like this. If I call this as loop number 1, this becomes loop number 2. Or I can make a third loop, which is the outer loop, which is loop number 3. Yes or no? Now, these three are not independent loops. If I add 1 and 2 loop, I'll get loop number 3. If I subtract loop number 1 from loop number 3, I'll get loop number 2. So basically, you only have two independent loops. You understand this? Yes or no?
Yes.
Now, how do I solve this circuit? I just start from any point in the circuit. Let me call this point as A. And then I start to draw random current. So I just say that I1 current is flowing in this branch. Now, my assumption may be absolutely ulta. I1 current may not be flowing like this. I1 current may be flowing in the other direction, but I don't have to worry about it, because if my direction is wrong, the answer will come negative. You understand this? Yes? So far, so good? So far, so good? Yes or no?
Yes, sir.
Now it reaches this point. Now, let me just not confuse you. Let me call this point as O so that you don't get confused. Okay, it reaches this point. Let me call this point as A. Now, can you tell me what can I call this point A? I can call this point A as
node.
This point A becomes a node, but let us not get into that. It reaches this point A, then what will happen? We can apply Kirchhoff's junction law here. So if I say that I2 current flows in this branch, how much current will come in this branch?
I1 minus I2.
I1 minus I2 will come in this branch, and then this current goes away. It reaches here, and then again it mixes, and I get the current I1 in my branch. Now, basically, as you can see, there are two unknowns, and the unknowns are marked in yellow. One unknown is I1 and the other unknown is I2. The only question now remains to find out the value of I1 and I2. Two unknowns, so we need two equations. So either I can go for loop number 1 and 2, or I can go for loop number 1 and 3, or I can go for loop number 2 and 3, depending on how you do it. I'll just write the equation. If I just write the equation for loop number 1, can you tell me what will be the Kirchhoff's equation for loop number 1?
I1 R1.
So basically, the Kirchhoff law says, Kirchhoff's voltage law says that summation of potential difference in a closed loop is 0, that there is no change in potential if I move in a closed loop. So if I start from point O, if I call the potential of point O as VO, in the direction of current, potential decreases, and if I go across a battery from negative to positive terminal, potential increases. Yes or no?
Yes, sir.
Potential rise is taken as positive, potential drop is taken as negative. On that same principle, if I apply Kirchhoff's loop law here, the answer would be V0 plus E1 minus I1 R1. Am I going correct? Yes or no?
Yes, sir.
Then I go down in this loop, then it will be minus I1 minus I2 multiplied by R3. That must be equal to potential at point 0. Potential at point 0 will cancel out, and this is my equation number 1. Yes or no?
Yes, sir.
This is equation number 1 that I got from loop number 1. Now, I cannot solve this equation because there are two unknowns, so I'll have to go for the second equation. Second equation can be made from loop number 2, but I'll just make it from loop number 3. So what is the equation that I get from loop number 3?
P1 minus I1 R1.
Yes. Okay, so again I start with the point O. Potential of point O is VO. Why I'm writing this ever and ever again? Because you must understand that every point has a potential. V0 plus E1 minus I1 R1, potential drop. Then I go in the upper loop. In the upper loop, bahar wala loop, minus I2 R2 minus E2, and then I come back to the point V0. V0 and V0 cancel. These are the two equations that you get. You can solve equation number 1, you can solve equation number 2 simultaneously, and you will get the value of I1 and I2, and your question is solved. Yes or no?
Yes, sir.
That is how you normally do it by Kirchhoff's law, but you already know it. Is why I'm telling you this. Okay. When I teach something, I make sure that everyone is clear as to what we are supposed to do. This is how we do it normally, and there is nothing wrong with it. The only problem is we might have a difficulty in solving two simultaneous equations because JEE, whether it's main or in some cases up till advanced, is a matter of time. You have to do things quickly. Now, I hope you have noted it down. How do you do things quickly here? Obviously, there are two unknowns, so there has to be two equations. Can I drastically reduce the number of equations? And that is where the Nodal theorem comes. Can I somehow reduce two equations to one equation? Is that possible? We all agree that there are two unknowns, right? So there must be two equations. Is there any way in this universe I can solve the same problem with just one equation? Is it possible? If it is possible, then how is it possible? It looks virtually impossible that I solve a problem which has two unknowns with one equation. I just can't do it. In this case, I can. And how I am going to do this? So please pay attention. Do not miss it. Okay. How I can do it? Now I'm going to do the same thing in a different way. The same thing in a different way. I understand that this point is a node. Let me call it as A. Yes or no?
Sir.
This is again a node. Yes or no? Let me call this as B. You all understand this?
Yes, sir.
Now what do? I earth B, just to simplify things. If I earth B, so basically what I'm assuming that the potential of point B is taken as 0. Yes or no?
Yes, sir.
I can do it. That means whatever I'm getting, whatever potentials I am getting will be with respect to O. Yes or no?
Yes, sir.
So if I call the potential of point A as VA, this VA is basically potential of A with respect to O, with respect to B, and B ka potential is taken as 0. Yes or no?
Yes.
That's it. Now, without telling you anything, can you tell me what is the value of VA?
What is the value of?
What is the value of VA? If I can get the value of VA, everything else is known.
Sum of the currents equal.
Hmm?
Sum of the currents equal 0.
Yes. So what is the value of VA? You already done that. You have already done that. Okay. So
Wait,
basically, what I'm going to do, I'm going to apply the same concept. I'll give you a minute to think about it. I1, I2, and I3. I'm going to apply the same concept that I applied upar. Same thing. Just have to be careful in applying it, nothing else. I just need to be careful while I applying this. I'm going to do the same thing. The same thing that I did here is the same diagram, it's the same concept. I'm just going to do it in the same way. I'll give you a minute to think about it. If you can do it on your own, nothing like it, you will never forget it. Even if you can't do it on your own, if you see it once happening, you should be able to do it again. A minute to think.
E1 by R1 plus E2 by R2.
Yes, tell me.
So that is E1 or E2.
Oh, that has to be 2, na? Make it 2. That has to be 2.
Sir, VA equal to E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2 plus 1 by R3.
That is correct. Now, does it make any difference if I just change the orientation of E2? If I make E2 as this, does it make any difference? Does it change anything? Or is the answer remaining same?
Change, sir.
What will be the change?
Negative sign will come soon.
Negative sign will come. So what I'm going to do is I'm going to give you, let me just make the same thing here. I'm going to give you the concept, and the concept still remains same. The concept still remains I1 plus I2 plus I3 has to be equal to 0. Now, what is the value of I1? That is the concern. Now, I'll just write the value of I1 here. What is the value of I1? So what do? I write Kirchhoff's law starting from point A, and I finish my Kirchhoff law at point B. Do we understand this?
Yes, sir.
I'm only going to law, not the Kirchhoff's loop law, but I'm going to draw Kirchhoff's half loop law, because this is half of a loop. This is not a complete loop. So how do I write the Kirchhoff's half law? Again, I go back to my previous thing and I remember how do I write it. So how do I write it? I start from point A. I write VA. Now I'm going in the direction of current. So that will be minus I1 R1. Yes or no?
Yes, sir.
Then I am going across the battery from the positive terminal to the negative terminal. That means potential drops. Yes or no?
Yes.
That will be equal to potential of point B. And remember, I have assumed that the potential of point B is 0. So that must be equal to 0. Yes or no?
Yes.
This is the yellow equation that I get. I don't have to write it again and again. If you understand it once, I will be able to replicate it again. So from here, I can get the value of I1. The value of I1 will be simply equal to VA minus E1 divided by R1. Yes or no?
Yes.
This will be the value of I1. Now, once I understand this, now I can easily write the value of I2. I just see whether the battery is getting added or battery is getting subtracted. I subtract it or add it to VA and I divide it by the entire resistance. Do you understand how I get the value of anything?
Yes, sir.
So first I write the value of I1. I1 is VA minus E1 divided by R1 because the battery is getting subtracted. What will be the value of I2?
VA minus
I2.
VA minus E2. VA minus E2.
So here
by-
also battery is getting subtracted. So I will get VA minus E2 divided by R2. Yes or no?
Yes, sir.
Then I move into the third branch, which you missed. Then I move into the third branch that you missed. Now here there is no battery, so nothing gets subtracted. So what will I get the value of what will I get the value of I3 as?
VA by R3.
VA by R3 plus VA by R3, that must be equal to 0. From here I can get the value of VA, and this VA is nothing but equal to summation of EI. Oh, I should not write it like this because there is no battery at one end. So I'll just write it in the normal form. In the normal form, it looks like E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2 plus 1 by R3. If I change the orientation or the connection of any battery, instead of it getting subtracted, it might get added up. Whatever happens, the answer remains same. Now, I've solved this question. Once I get the value of VA, I can easily get the value of E1. Yes or no? I just put the value of VA here, I get the value of E1. I just put the value of VA here, I get the value of V2. If I just put the value of VA here, I get the value of I3. Yes or no? So the equation, the problem which was done by using two equations is now done by using only one. Do you understand this?
Yes, sir.
I'll give you a minute to note this down. Please note it down.
Completed, sir.
Okay, so we have noted this down. Yes or no? Okay. Now what I'll do is I'll just give you a problem where this was also a problem. I'll just give you a numerical in terms of solving, and I hope that you can give me the answer in a flash. So what I do, this is 2 ohms, this is 2 volt, this is 6 ohms, this is 3 ohm. I reverse the direction, this is 3 volt. Can you now tell me what are the currents in all the three branches, whatever you call it? Can you tell me the currents in all the branches? I'll give you a minute to solve it. Anyone with an answer?
Yes, sir.
Yes, what is the answer?
In 2 ohms, 0, sir.
2 ohms, the answer is 0. Okay, I'll assume that this is correct. The answer is 0 here. So there is no direction.
In 3
What
ohms,
about here?
In 3 ohms, 1 by 3 ampere.
1 by 3 ampere in which, like this? In which direction? Like this?
Yes, sir.
Okay, 1 by 3 ampere. So in this, it will be 1 by 3 upwards.
Yes, sir.
Okay, let me check it. So first of all, let me write the equation here. The equation will be, if I call this point as A, this becomes VA minus 2. I don't have to, let me write VA minus 2 divided by 2 plus VA, and this is not minus, this is going to be plus VA plus 3 divided by 3 plus VA divided by 6 should be equal to 0. Yes or no? Yes or no?
Yes, sir.
So from here, I can find out the value of VA. What is the value of VA coming as? What is the value of VA coming as? So I can write it like this, VA by 2 plus VA by 3 plus VA by 6 is equal to, I think, 0, yes? Yes or no?
Yes, sir.
So VA basically is 0. VA is 0. Did you get that answer? VA is 0? There is no current flowing. Okay, VA is 0. So if VA is 0, how much will be I1? Let me call this as I1. Let me call this as I2. And let me call this as I3. Obviously, your answers were not correct. Let me call this as I3. What will be the value of I1? I1 will be equal to -1. Yes or no? And I2 will be equal to +1. Yes or no? So how is the current flowing? The current is flowing just like that, and there is no current in this branch. Do you get this? How I have solved this? And I don't know how you have solved this. How did you get it? I 1 by 3. How did you get it 1 by 3? What was the? How did you get it 1 by 3, bacha?
Battery.
Yes, beta. I am not able to hear you. Sorry.
I taken VA minus 3 by 3.
That's it. If you do a mistake, you are done. So it's not minus. You have to see the orientation of the battery. If you take it plus and minus, it makes a hell lot of a difference in life. So that is how you do it. Do we understand this? Yes or no?
Yes, sir.
Now it becomes pretty clear how I can use this nodal theorem in various cases. Are you confident that you can solve this question now? Any question? Now see, if I make a not so good looking diagram, even this diagram, any question could be solved here. See, for example, this one. Two, 3, 3, 4, 4, 5, 5. Now, if I give you a diagram like this, you might feel a lot. Basically, I can make more branches as well. That doesn't mean I can make 50 branches here and make 50 branches like this. That does not make any difference to anyone's life. The point here that you must understand in this question, even if there are a lot many branches that you see, the number of nodes still remain how many? Number of nodes still remain?
One only.
2.
2.
The number of nodes still remain 2. So even this question can be solved with how many equations? Just one.
One equation.
Just one equation. I don't need to get confused. Can still solve this equation using one equation. Can you tell me what is the value of VA? Once you get the value of VA, you can calculate the other things. So in one branch, I have 2 ohms and 2. I'm just giving you random values. In the other branch, you have 3 and 3. The other branch, 4 and 4, 5, 5, 6, 6, 7, 7, 8, 8. I can make infinite number of branches in this way. Doesn't make any difference. So my VA will be equal to how much? You can just straight away write 2 by 2 plus 3 by 3. All of them are getting subtracted, so they will be added up. 3 by 3 plus 4 by 4. 4 by 4 plus 5 by 5 divided by 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5. Isn't it? Yes or no?
Yes, sir.
Once you get the value of VA, you must be able to calculate the other unknowns. Yes or no? Anyone having any doubt, please raise.
No doubt, sir.
Okay. Now, since I have opened this Pandora's box, I'll just solve everything that is possible. So there can be a question which is like this. And let me now make this question. And now let me know what the answer would be in this case. Now let us, for example, say I have made, and I'll give you general values E1, R1. This is E3, and this is R2, and this is E2. So remember, I've changed something here. What I have changed here? I have taken one resistance out. There is no resistance in the third branch. Now, how do I solve it? Now, how do I solve it? I'll give you a minute to think about it. Yes, but any idea how you do this? So resistance goes away, 1 by 0 is undefined. I can't define it. How do I solve this? How do I solve this?
By taking loop law.
Yes, you can solve it using loop law, not a problem. Yes, you can do that. But how do you solve it using nodal? Here, the nodal becomes very simple. If you just look, if you call this point as point B, this is point A, this is point B, the nodal becomes simple. In fact, it becomes very simple because now, since there is no resistance in this branch, which branch I am talking about? I'm talking about this branch. There is no resistance in this branch. If I just apply the nodal theorem here, I mean, if I apply Kirchhoff's law from here, I can easily see that VA minus E3 will be equal to 0. Yes or no? So basically, I get the value of VA as E3, as simple as that. My potential of A is already known. It is E3. If this is E3, now I can find out the value of I1 and I can get the value of I2. What is the value of I1? VA minus E1 divided by R1. What is the value of I2? VA minus E2 divided by R2. Did you get this?
Yes, sir.
It becomes pretty damn simple. You can't get a simpler question than this. Yes or no?
Yes, sir.
We have solved it. No Kirchhoff's law, nothing. Simple. So if there is no resistance in any of the branch, the question still becomes more simple. Now, for example, if I would have added one more branch here, if I say I've added a red branch here and the resistance of this branch is, let us say R3, you can find out the current in this branch as well. What is the current I3 in this branch? The current I3 in this branch will be equal to VA divided by R3. Do we understand this?
Yes, sir.
Now, if I ask you, the current in this branch is I4. What is the value of I4? I4, the current in the blue branch, the branch where there was no resistance. What is the current in that branch?
0.
No, it's not 0. If there is no resistance, that does not mean there is no current. Remember, I1 plus I2 plus I3 plus I4 still remains equal to
0.
0. Bacha, you know I1, you know I2, you know I3. So you can tell me the value of I4. Yes or no?
Yes, sir.
What will be the value of I4? It will be the negative of all these things in the summation. Yes or no?
Yes, sir.
So if there is no resistance in any of the branches, the question becomes pretty damn simple. Using which concept? The concept of nodal theorem. Do we understand this?
Yes, sir.
Okay. Now, let me go to probably the most difficult question that is possible that can come in your exam. Now, how does the most difficult question look like? We'll again start with the same phenomena. This is one branch. This is one more branch. Let me just write this is one more branch. Here I've added a resistance just to make things different. Here there is one more branch, one more battery, and in between these two, I have one more battery. I've made a very complicated looking question. E1, R1, E2, R2, E3, R3, and I have R4 and I have E4. Oops. Now the question starts to look very complicated and you cannot even start solving it using Kirchhoff's law. Yes or no? Because now your Kirchhoff's law will just look very complicated, isn't it?
Sir, question is not visible on the screen, sir.
Question is not visible on the screen. Oh, my bad. Now it is visible, right?
Yes,
Now
sir.
you can't even start applying Kirchhoff's law because it just gets too complicated if I start applying Kirchhoff's law. Yes or no? Why it is getting complicated? Everything else is okay, but I have got one battery here and one resistance here, which just makes the question look very complicated. And I can see, I don't know how many loops, 1, 2, 3 loops. Probably Kirchhoff law will take 3 equations to solve this. And again, if you make a simple mistake in any of the equations, you are doomed. Doomed. How do I solve this one? Tan. So this is probably the most difficult question that can ever come. I'll give you a minute to think about it. How many equations do you think will be needed in the nodal theorem? 1, 2, 3, 4. How many? How many nodes you see? How many nodes you see?
2.
This is A, one node. We agree on this? This is B, the other node. Agree on this? Now, if this resistance was not there, then this question and the previous question were same. Yes or no?
Yes, sir.
But this resistance makes a hell lot of a difference because now this becomes the third node. Yes or no?
Yes,
If the
sir.
resistance was not there, C and B become the same point because there is no potential difference. But now it becomes different. Now tell me what is the value we will get and how will you solve it? 3 nodes. So the logical question would be that you will need two equations, right? Number of equations is normally 1 less than the number of nodes. Yes or no?
Yes, sir.
Because one of the nodes is having value 0, so you only need 2. So basically you might think that you will need 2 equations here, but this question can still be done with just 1 equation. This question can still be done with just 1 equation. Am I having attention of the entire class? Can you all raise hand that we are all there in the class? This equation can still be done using just 1 equation. Just 1 equation. And just to make it look different, what I'll do, I'll just put the values here so that we can solve this not in terms of E1, E2, but in terms of the real value. So I'll just call it as 1 ohm and 1 volt. I'll just call this as 2 ohm and 2 volt. Oops, 3 ohm and 3 volt. That gives me similarity that, I don't 3 volt. This is 4 volt and this is 4 ohms. I can still solve it using 1 equation and 1 equation only, but then you'll have to understand where you are going to make that equation and how are you going to make that equation. I'll give you a minute to think about it. Think. Anyone got any idea? Shall I do it? You don't believe that it can be done with one equation, right? Do you believe that it can be done with one equation?
The
No?
potential,
Yes, say.
potential at A is equals to minus 4 volts.
No. Again, you have to tell me which point is your zero. Which point is your zero? Your answer can be correct depending on where your zero is. Which point is your zero? Now I have the option of making 2 points. So any of these three can be zero. Any of these three can be zero. So I can make B as 0, I can make A as 0, I can make C as 0. Now you can take your imagination and make any of these 0. Which one you want to make 0? Tell me. Which one you want to make it as 0? A, B, or C? Up till now, whatever questions we have done, we have always made B 0, but that is not the only way you can do this. Potential. You can take your reference as 0 at any point. Which point you want to make 0? Just tell me fatafat because your time is running out. Okay, I'll not change anything. I'll just keep B as 0 so that everything looks simple. So point B is taken as 0. We all understand this? Yes or no?
Yes, sir.
Then the potential of point A becomes VA. Do we understand this? Yes or no?
Yes, sir.
I know this is 0. Oh, why the color is not changing? I know this is 0. I know this is VA. Can you now tell me what will be the potential of point C? You've just done it in the previous question. Potential of point B is 0. Potential of point A is VA. What is the potential of point C? And the answer is? And the answer is? VA plus 4. Do we understand this?
Yes, sir.
How did I get it? I go in the green branch. I start from point A and I end my journey at point B. VA plus 4 is VC. Do we understand this?
Yes, sir.
Now, open your eyes and you see. What do you see? You only see one unknown. Yes or no? You open your eyes and you just see one unknown, and that one unknown is VA. If you know VA, you know VS plus 4, you know everything. Yes or no?
Yes, sir.
So the only thing I need to do now is to get the value of VA. Yes or no?
Yes, sir.
Now the question is, from where can I make the equation? Where should I make the equation? At node A, if I make the equation one branch, I will not know the current because in one branch there is no resistance. So now I use what I call common sense, and I make the equation. Normally, I make the current as point A as going out. So I always make the current at point B as coming in. So all the currents are coming in. Let me call, oops. This current as I1, this current as I2, and this current as I3. All coming in. They can all go out, they can all come in, doesn't matter. Now again, I know I1 plus I2 plus I3 has to be 0. Yes or no? Yes or no?
Sir. Yes, sir.
What is the value of I1? What is the value of I1?
VA minus 3 by 3.
Well done. So I1 is VA minus 3 by 3. That is my blue. Yes. Now let us move on to the second one. What is the value of I2? I2 will be my pink. No. Yellow. What is my I2?
VA minus 2 by 2.
VA minus 2 by 2. That is my yellow. Now comes the green, no, the blue fellow. No, blue's already done. Then the green fellow. Then comes the green fellow, dirty fellow, green fellow. Yes, I3, green Hulk.
VA plus 4 by 4.
That is absolutely correct. I have solved this complicated circuit with just one equation. Yes or no?
Yes,
The
sir.
only unknown here is VA. Do we understand this, or this has gone above our heads? Do you understand this? Can I have some raised hand that we understand this?
Yes, sir.
Everyone in the class? Well, that was the Pandora's box. I think we have done enough. You cannot get a more difficult question than this, because that can still be solved, but you will not have, no one will have enough time to solve this. That's it from my class today. We're supposed to do radiation, but we have done this. Everything is a part of your curriculum. Since I had done one thing, I had to make sure that you know how to imply one thing in the other thing. So if there comes a question, remember the way I have done it for resistance, the same way it could have been done for capacitance. So instead of resistances here, if we had capacitances, even then the same question could have been done. Now how it is to be done, I leave it to you. How nodal theorem is to be applied for capacitances, I will leave it to you. I hope you can make sense and tell me how it can be applied for capacitances. Till then, I'll see you in the next class. That I think will be on Monday. Enjoy your weekend. Study. Try some circuits, electrical circuits. See if you can apply nodal theorem and see if you can get your answers easily in a flash. That's it from my end. Thank you. I hope you love this class. Take care. Have a nice day.